Section 5.2 is on page 195, talks about series solutions near an ordinary point, part 1. We already did part 2 ahead of time, so we know what ordinary means. Suppose you're given the following series and it equals 0. This means a sub n equals 0. You setting x equal to x naught, or the variable equal to 0, everybody knows that. Given equation 1, make sure that's a 1. There's p of x, there's q of x. If the coefficients of p of x and q of x are both analytic at the point x naught, then x naught is called an ordinary point. For the equation, a point which is not an ordinary point is called a singular point. To find a series solution to this differential equation, we're going to let y equal the following series, or if they center it at anything other than 0, if they center it at x naught, we could go around it. Here it's centered at 0, here it's centered at x naught. So note that a couple of things I need to remind you of. After our discussion in class, I figured that some of you said you don't remember taking this, or your teacher didn't spend a lot of time on this, so I want to review with you just a bit. If this is the series, if I take a derivative of that, do you notice that the derivative will make that a 0 plus a sub 1 plus 2a sub 2x to the 1 plus 3a sub 3x squared, and the list goes on. So when I take a derivative, I do notice that I lose a term. When I write this out, I'll say that's the series. The derivative, this is the variable. Bring the power down, subtract 1 from the power. However, since I lost a term, I need to compensate and show that on my series without listing. And if I take another derivative, so let me just bring this down just a bit. If I take a second derivative, wouldn't a second derivative make that a 0? Wouldn't that be 2a sub 2 plus 3 times 2a sub 3x to the 1? And then this goes on. Since I lost another term, if I want to just work it out using... Oh boy, I said something and I wrote something else. Does that happen to you? This is the series. Bring the power down, subtract 1 from the power. And to compensate for what you missed, you're going to boost this index another 1. You need to list a few terms to know when do you lose terms, when do you not lose terms. And if you recall, we did this in section 11.9 specifically in our calculus. If you integrate the series n equals 0 to infinity a sub n x to the n with respect to x, the constant plus the series n equals 0 to infinity a sub n, you would add 1 to the power and divide by the new power. So that's from the previous class. Now I want to look at a few problems. So 1 through 11 on page 204 says, part A, seek power solution to the given differential equation about the given point x sub 0. In this case, you're centered at the origin, which means y equal the series n equals 0 to infinity a sub n x to the n is the solution. Find the recurrence relation that must satisfy the coefficient, that the coefficient must satisfy. B, find the first 4, just 4 non-zero terms of each arbitrary y1 and y2, unless it terminates sooner. Alright, let's see what we need. We need a derivative. Since this is the traditional, I know how this works. So I need a derivative. The first derivative is the series, and I know I'm going to boost the index 1 up because I just did that for you on the previous. And I need a second derivative. That's going to be the series n equal 2 to infinity. So the reason I'm not listing the terms here, I already know that this doesn't lose any. This loses a term every time you take a derivative. And now I'm just going to fit them in. So this is right there. That's the series n equal 2 to infinity, n into n minus 1, x to the n minus 2, plus 3 times the first derivative, and I want to know where does that equal to 0. So homogeneous solution basically. Again, I need to combine those somehow. I'm going to really set everything to n. That's kind of how the book does it. I would have done it differently, but I want you to really match the book. I'm going to boost this up by 2. Boost this up by 2. N plus 2 minus 1 is n plus 1. And boost this up by 2, n plus 2. And this series to compensate will be n equals 0 to infinity, plus 3 times the series. This is x, and I just boosted this up 1, up 1, up 1. Oh, I don't like that last one. There we go. And this will compensate by shifting 1 down. So it looks really simple for the most part because it kind of matched. I'm going to take x to the n out of both of those. And I'll see what else I could take. Series n equals 0 to infinity. So I was able to match those. And I took this out of both. Now I'm looking inside. I noticed that I could take n plus 1 out of both of those. Do you see that? That would leave me with n plus 2 plus 3 times, oh, I lost track. I left, oh boy, okay, I can fix that. I have plenty of space. I left out a single piece. I left out in the second derivative, I left out a sub n. So when I boosted this up by 2, this piece right here, oh come on, it's not that hard. Move. That would be a sub n plus 2. So when I took this out, I have this times a sub n plus 2 plus 3, and here I have a sub n plus 1. There we go. And that should equal 0. So what I'm trying to do, I'm trying to figure out how this is going to work. If you say x equals 0, we all know that. It must be that n plus 1 times n plus 2 into a sub n plus 2 plus 3 a sub n plus 1 equal to 0. So n plus 1 equals 0. If I divide both sides by that, that's gone. I'm looking at n plus 2 a sub n plus 2 equaling negative 3 a sub n plus 1. And if I divide by n plus 1, that's the recursive formula. That's kind of what they want in part A. Right? So in part A they say find the recurrence relation, basically the recursive formula. That's A. Part B, it says find the first 4 terms. Part B, well, let's see. If I start with my very first evaluation, and I'm going to go for, if I let n equal 0, this says a sub 2 equals negative 3. So I put a 0 there, a 0 there, and a 0 there. Negative 3, a sub 1 over 2. Right? And if I take a sub 3, that means I put a 1 there. That's going to be negative 3 over. So it seems whatever this is, right? That's a 3. And this is 1 less than that. But I know what that is. That's negative 3 over 3 times a sub 2 is actually right there, negative 3 over 2 a sub 1. If I look for a sub 4, that is negative 3 over 4 a sub 3. That is negative 3 over 4 a sub 3 is right there. Right? Those are the first 4 terms if I really look at them. So if I list the solution now, if I say, well, let's see how this works. Y equals a sub 0 plus a sub 1 x sub 1 plus a sub 2 x squared, a sub 3 x cubed, a sub 4 x to the 4. It seems they only want us to worry about the first 4 terms. Okay. A sub 0. We got a sub 1. We couldn't get that. But a sub 2 we got to be what? A sub 2 is right there. We got it to be negative 3 over 2 a sub 1 times x squared. A sub 3 is right there. That is a negative 3 over 3 times negative 3 over 2 a sub 1 x cubed. And the fourth one is right there. Negative 3 over 4, negative 3 over 3, negative 3 over 2 a sub 1 times x sub 4, and the list goes on. So, if I look at this, it seems y is going to equal a sub 0 plus, all of these have what in common? They all have a sub 1. If I factor a sub 1 out, I'll be looking at x minus 3 over 2x squared plus negative times a negative, right? This is going to be 3 squared over 3 times 2, which is 3 factorial x cubed, minus 3 times 3 times 3 is 3 cubed. That's why we don't simplify. 4 times 3 times 2 is 4 factorial x to the 4th, and the list goes on. So I could say that y equal a sub 0 plus a sub 1 times the series n equal to infinity. So the power of x is really x to the n. So 1, 2, 3, 4 is x to the n. X, if you have 2, 4, 6, 8, that will be x to the 2n. So even is 2n, odd is n, 2n plus 1 or 2n minus 1, that's from 5b. And if I look at the coefficients of how that works, whatever this is, it seems the denominator is that factorial. And the top, this is, if this is 2, this is 3 to the 1. If this is 3, this is 3 squared. If this is 4, this is 3 cubed. There's a 3. Whatever this power is, this is 1 less. Right? And that would mean, oh, and it's alternating. Negative 1 to the n should do. Let's test it. If I let n equal 3, I'm getting negative 1 to the 3rd, 3, put a 3 there, that's squared over 3 factorial x cubed. Does that match? Well, it doesn't. This is negative, that's positive. An easy fix back from 5b. And plus 1 or minus 1 will do, it makes no difference. So there it is. So I could say in this case that y sub 1 equal a 1, the coefficient of that, and y sub 2 is the series n equal 1 to infinity of negative 1 to the n plus 1 times 3 to the n minus 1 over n factorial x to the n, because y equal a sub 0 y1 plus a sub 1 y2. That's how you write the solution. So if you look at it, they're right there. y1 must be what's multiplied by a sub 0, and y2 must be what's multiplied by a sub 1. And that's basically it for this problem. We have one more to go, and this is just as much fun. This is a bit longer, but that's okay. Second order, we have plenty of time, right? So again, I'm gonna let y equal the series n equals 0 to infinity a sub n x to the n. The first derivative, series n equal 1 to infinity. I'm gonna bring the power down, subtract 1 from the power. And I need the second derivative. That's going to be the series n equal 2 to infinity n into n minus 1 a sub n x to the n minus 2. And now if I plug them in, that's twice the second derivative on the right. I did it again. There's a song like that, no? Britney Spears, oops. N equal 1 to infinity n a sub n x to the n minus 1 plus 3 times the series n equals 0 to infinity a sub n x to the n, and I want that to equal 0. And if I combine those, that is the series n equal 2 to infinity of twice n into n minus 1 a sub n x to the n minus 2 plus the series n equal 1 to infinity, multiplying those out, n a sub n x to the n plus the series n equals 0 to infinity, 3a sub n x to the n equals 0. And that's why we did 5.3 before 5.2, because now we already know how this works. Those two are matching very good. I need to adjust this by shifting this 2 up, 2 up, 2 up, 2 up, and 2 down. That makes this the series n equals 0 to infinity. Constants don't get affected. 2 up. If I replace n by n plus 2, that will be n plus 1. Replace that by 2 x to the n. And the other two are matching, no problem. And now that I have them all matching with the x's, I need to adjust. Well, this is what I noticed. This is n equal 1. I need to drop a term off of this and a term off of this. If I do that, if I throw n equals 0, that will be a 2 times 2 times 1. If I put a 0 in there, that is a sub 2 plus the series n equal 1 to infinity, 2 into n plus 2, n plus 1, a sub n plus 2 x to the n. The second term I'm going to leave alone because that's what I'm trying to match. Oops. N, a sub n x to the n. And I'm going to drop a term out of that, throw 0 in, that's 3a sub 0 plus the series n equal 1 to infinity, 3a sub n x to the n equals 0. Now, this is 4a sub 2 plus 3a sub 0 plus, now I have all of these series matching, so I copy that down, series n equal 1 to infinity. I have all the x to the n matching, and I'll try to see if I could take something else out. Does anything else matches? Well, not really. So this is actually 2n plus 2 into n plus 1 a sub n plus 2 plus n a sub n plus 3a sub n. Okay, and that equals 0, of course. And now, if I go ahead and take, for this to be 0, I need those. I need 4a sub 2 plus 3a sub 0 to equal 0. That means a sub 2 is negative 3 over 4a sub 0. I got a sub 2, very good. And on top of that, I have twice n plus 2 into n plus 1 a sub n plus 2 plus, can't I factor an a sub n out of this? Wouldn't that make it n plus 3 equals 0? That means a sub n plus 2, move this to the right, and divide by this mess. That is twice n plus 2 into n plus 1. And that will be my recursive formula right there. So I got the first part out of the way. Now what? I need to list a few terms to figure this out. So let's see how we're going to do this. I'm going to start with letting n equal 0. Well, a sub 2 is right there. You'll get the same thing. Put a 0 there, that's negative 3. A 0 there, that's 2 times 2, which is 4. A sub 0. I already have a sub 2. Let's go for a sub 3. A sub 3 is actually putting a 1 there, right? That's going to be negative a 4 a sub 1 over a 1 there and a 1 there. That's 2 times 3 times 2. Got it. If I want to figure out what a sub 4 is, a sub 4 is, put a 3 right there. That is negative 4. I'm sorry, that's negative. If you put a 3 right there, 3 plus 3 isn't that, let me see, so a sub 4, put a 2 there. That's a 5 a sub 2 over. If I put a 2 right there and right there, that's 2 times 3 times 2 times 4 times 3. But I know what that is. I know what a sub 2 is. A sub 2 is actually negative 3 over 4 a sub 0. Very good. I want to figure out what a sub 5 is. A sub 5, that means you're really embedded for this n. A 3, that's how you get a 5. A 3 for n, 3 plus 3 is 6, a sub 3 over. A 2, 3 plus 1 plus 2 is a 5, and 3 plus 1 is a 4. But I know what a sub 3 is. A sub 3 is a negative 4 over 2 times 3 times 2 a sub 1. So I am in a good shape. I'm going to figure out a sub 6. A sub 6, that means you put a 4 there. That is negative. 4 plus 3 is 7, a sub 4 over 2. A 4 in there, that's a 6. A 4 in there, that's a 5. That's negative 7 over 2 times 6 times 5. A sub 4 is right there. It's all of this mess. Negative 5 over 2 times 4 times 3 times negative 3 over 4 a sub 0. And maybe one more just for the heck of it. A sub 7, you put a 5 right there. That's going to be negative. 5 plus 3 is an 8. Well, look at it. 4, 5, 6, 7, 8. And 2 times, and this is 6, right? Look, 3, 4, 5. This is 7 times 6. A sub 5. But that's negative 8 over 2 times 7 times 6. A sub 5 is right there. All of this mess. Negative 6 over 2 times 5 times 4. Negative 4 over 2 times 3 times 2. A sub 1. So everything is in terms of a sub 0 and a sub 1. I know that y equal a sub 0 plus a sub 1 x to the 1 plus a sub 2 x squared, a sub 3 x cubed, a sub 4 x to the 4, a sub 5 x to the 5, a sub 6 x to the 6, a sub 7 x to the 7, and the list goes on. Well, let me fill in the blanks. Y is going to equal a sub 0, I didn't find anything for it. A sub 1, I didn't find anything for it. But a sub 2, I'm going to start filling in the blanks. That's negative 3 over 4 a sub 0 x squared. A sub 3 in order. Negative 4 over 2 times 3 times 2 times a sub 1 x cubed. A sub 4 is that mess. A sub 4 is a negative 5 over 2 times 4 times 3 times a negative 3 over 4 a sub 0 x to the 4th. A sub 5, I covered it. Oh, it's right there actually. It is a negative 6 times a negative 4 over 2 times 5 times 4 times 2 times 3 times 2 a sub 1 a sub times x to the 5th I'm going to list a sub 6 and a sub 7. So a sub 6 is actually a negative 7 times negative 5 times negative 3 over 2 times 6 times 5 times 2 times 6 times 5 times 2 times 4 times 3 times 4 a sub 0 x to the 6. And I'm not going to list, I could list a 7th, but let me see, does it fit? Yeah, why not? Minus 8 times negative 6 times negative 4 over 2 times 7 times 6, 2 times 5 times 4, 2 times 3 times 2, a sub 1 x to the 7, and the list goes on. Let me make some more space. So I'm getting y to equal, I'm going to take out all the a sub zeros. A sub 0 times a 1 minus 3 over 4x squared plus 3 times 5 over 4 times 3 times 2 times, I'm going to write that as 2 squared, and here I'm going to make this 2 times, I'm trying to get a factorial out of each of those. That is x to the 4th, and if I look at x to the 6th, I'm going to say that is a negative, it's right there, negative 3 times 5 times 7 over, and if I take 6 times 5 times 4 times 3 times 2 times, and let me see how this works. I have a 4. I copied this twice for some reason, my mistake. So still 6 times 5 times 4 times 3 times 2, very good. I still have left 4 times 2, that's 8, that's 2 cubed, and that is x to the 6, plus the list goes on, plus a sub 1 times, and let's go with the ones. The 1 has an x, this piece, minus 4 over 3 times 2, that's the factorial, times 2 to the 1, x cubed, x to the 5th is plus 4 times 6 over, I need 5 times 4 times 3, no, 5 times 4 times 3 times 2, and I'm left with a 2 and a 2, that's 2 squared, x to the 5th, and one more term, is x to the 7 negative or positive? Negative. It's going to be 4 times 6 times 8 over, and let's see, I'm looking at 7, 6, 5, 4, 3, and 2, 7 times 6 times 5 times 4 times 3 times 2, and I'm left with a 2 times 2 times 2, which is 2 cubed x to the 7, and the list goes on. So, if I really look at this, I could say that this is y1, and this is y2. So, y1 is right there, and y2 is right there. I could say y1 is going to equal the series n equals 0 to infinity. X to the, so x is raised to an even power. We said that's 2n in this case, right? And it seems the denominator is x squared 2 factorial, x to the 4th 4 factorial, x to the 6th 6 factorial, x to the 2n 2n factorial, x squared 2 to the 1, x to the 4th 2 squared, x cubed 2, so whatever this is, there's a 2 raised to half of that, which is just n. It is alternating, and the top seems to be a form of factorial. This was binomial, 3 times 5 times 7 times what? 3, 5, 7. This is a arithmetic sequence. A sub n is a sub 1 plus n minus 1 times the common difference. That's going to be 3 plus n minus 1. What are you adding every time? A 2. That is 2n minus 2 plus 3 is plus 1. Does that work? Well, let's test it. Let n equal 3. I'm going to get a 3 in there. 2 times 3 is 6 times 1 is 7, so that's 3 times 5 times 7. A 3 means it's negative, over a 3 in there, 6 factorial, 2 to the third, x to the 6. Is that the coefficient of x to the 6? You glance right there and you notice it is matching. Is it negative? Yes, it is. Perfect. And we're going to say that y sub 2 is going to equal the series n equal to infinity. And let's see how this works. X to the 1, x cubed. The power is odd. Odd is 2n plus 1, or 2n minus 1. It seems whatever the power is, I have that factorial. X cubed, 2 to the 1. X to the 5th, 2 squared. X to the 7, 2 cubed. So 2 to the n, right? N equal 1, n equal 2, n equal 3. That matches. It is alternating as well. That's negative 1 to the n. And I'm going to have a 4, 6, 8, dot, dot, dot. Well, this here is 2n. If I put a 2n right there, what would happen? Let's test it, see if it works. If I let n equal 3, I'll get negative a 3 in there. That is a 6. That's 4 times 6 over 3 in there. 6 plus 1, that's 7 factorial, 2 to the third, and a 3 in there will get you x to the 7. Let's look at the coefficient of x to the 7. The denominator matches. It is negative, but it has an 8. So it's really 1 higher. I need to boost this up by 1. I replace n by n plus 1. So instead of 2n, that will be 2n plus 2. And let's see if I can get, what's the lowest I can go? This is a form of factorial. I can't have factorial be negative. If I let n equal 0, I get a 2, but there's no 2 there. So I must start at 1. Let n equal 1, I'll get a 4, which means this coefficient is not there, so I add that on. And there it is. And our homework on this section is going to be page 204, number 1 through 9. And just like I did in the homework, you're going to only do part A and